Today we're here in Coco do Sol in Santa Catarina to show you how porcelain tiles are made. Shall we take a look? The base of the ceramic tile or porcelain tile has 8 or 9 different ingredients. As you might have guessed, the main one is clay. In my case, I'm standing on top of a giant mountain of clay here. There are several different types here. They get mixed together during the process. A second very important raw material is feldspar, which is nothing more than ground granite, ground stone. Looking at it, it looks like coarse sand. It's used in porcelain tiles, but not in regular tiles. It's important because when the porcelain tile goes into the kiln, this melts inside the piece and gives it a lot of strength. In regular tiles, an important raw material is limestone. It's mixed into the mass to release carbon dioxide and give the piece porosity. The porosity will make it have several little wrinkles on the back, and this helps the tile stick to the wall. The recipe is entered into the computer, and the ones that will measure the amount of ingredients are these boxes here, which are called hoppers. They're kind of square-shaped funnels, and at the tip of each one, there's a motor that will pull the raw material and drop it onto a conveyor belt that has a scale. This scale is what will determine the speed of the belt, and that way we can control the amount of ingredients that are dropped onto this main conveyor belt here. It's strange to think this will become the porcelain tile on your floor. All the material gets ground up in this mill. It's continuous, meaning the material doesn't stay still inside, it keeps moving and comes out at the other end. Inside there are several balls made of aluminum oxide, alumina. There are 4 different sizes, and they're constantly being added to the mill automatically by the computer. Then they come out all worn down and shattered on this side here, and a sieve collects them. See how this comes out on the other side? I was going to call this stuff mud, but I just got scolded because mud is an offensive term in the ceramics world. Mud is that clay you find on the road. This here is called barbatine, slip. It's all the ingredients already very well mixed, carefully formulated. They're going through a vibrating sieve. First, there's a 90 mesh screen, which means there are 90 tiny holes per square inch. Underneath it, there's already a 100 mesh screen, which means 100 tiny holes per square inch. This is used once again to remove impurities from this mixture here, which is called slip and not mud. An interesting thing is that here they use a deflocculant. A deflocculant is a substance that serves to separate the particles that are in the water here and keep them well dispersed, separated from one another. It's the opposite of what we saw in water treatment, where there's a flocculant that brings the particles together and makes the water clean. Here it's not like that. The idea is for the water to get as dirty as possible to have a perfect mixture. Man, this stuff flies all over us. I'll put my hand close here, just so you can see how my hand will look. Man, seriously, tell me in the comments if you don't feel like drinking this stuff. It looks like a giant chocolate fountain. This is the slip tank. This mixture is stored here, and they have capacity for 200 to 240 tons. The problem is that you have to keep stirring it all the time, because if you don't, the solid parts will settle. They'll sink, and then you'll lose the mixture. So this here looks like a huge blender. The one that's going to transport the slip to the next stage. This pump here, it has ceramic pistons. It's important for it to be made of this material because it wears down over time without causing any problems. It's funny to see. It looks like a car piston, but in the middle, there's ceramic instead of metal. That chocolate we just saw needs to be turned into powder. And guess how that's done? Exactly the same way as powdered milk. It's a spray dryer. So this funnel that's right behind me is going to do that. Up there, the slip is sprayed in all directions into very hot air. And this will make it dry very quickly and fall down here. Look how it's going to come out. It's about 80 degrees here. Too hot to keep your hand there. It looks dry, but it's not. This still has 7% moisture. I always thought that to make porcelain tiles. You just had to take a kind of clay, put it in a mold, and bake it. But it's actually quite different when it comes to shaping it. That powder we saw just a little while ago, it comes here and is placed inside a mold. Then a press will compress that powder, and and that's when the piece will take shape. The press is the one right behind it. It has a force of simply 400 kilograms per square centimeter. Just so you have an idea, atmospheric pressure is 1 kilogram per square centimeter. There, it's as if we were about 4 kilometers below sea level. Look at this. This piece just came out of the press. It hasn't been fired or anything. It's just pressed with 400 kilos per square centimeter. It already has good resistance. I'll break it here by hand, just so you can see. This reminds me of a big pasoka, but it's much harder and much denser. They managed to separate a mold for us here. Look how cool that is! This part will go on the back of the porcelain tile. It has a texture that's meant to improve adhesion. On the machine, it stays underneath. This is the part that will show. This is porcelain tile that looks like wood. It has a wood texture. So we can see the grain. This part stays on top of the press, so it's like a stamp. It will press the spray-dried powder, and it will get all these grooves. To gain strength, the pieces need to go through this dryer. They spend an hour moving inside here. At about 170 to 175 degrees Celsius, the piece comes out at around 90 to 95 degrees Celsius, and then it gets a thin layer of water. That's to seal any pores, because right after that, it will get the engobe and then the glaze. The engobe is a kind of preparation for the piece, and the glaze goes on top. That's the actual color of the porcelain tile that we know. In this case, they've already mixed the two things. This here is engobe mixed with glaze. It flows over the piece like a waterfall, and then the piece is painted. This is really mesmerizing. You could watch it for hours and hours without stopping. Go take a look. You know, it really makes you want to touch that thing to feel the texture. So, I came up with an excuse here so I could touch it. We're going to measure the viscosity of this liquid. The glaze. It's glass powder mixed with water, and it's very dense. It's about twice the density of water. That is 2 grams per cubic centimeter, or 2 kilograms per liter. And theoretically, it takes 50 to 55 seconds to go through this little hole here. It's very viscous, it's very thick. This is called a Ford cup. It's used exactly for measuring this. Let's take a little bit to see. Man, this looks like a really high quality paint. Or condensed milk mixed with paint. It's very viscous. These 20 fans you're seeing here are used to remove the moisture from the piece. And at the same time, slightly lower the temperature. Because the next step is to go through a giant inkjet printer. That's what you're seeing here. It also works with the CMYK standard, which is the same one you have at home, which is cyan, magenta, yellow, and black. Inside here, the print head will pass over the piece. You can't see it, just like at home. You can't see the print head passing over the paper. But on the other side, look, it came out with a wood texture. Each type of piece receives a different finish. This one needs to be rough to be non-slip. So it gets a mixture called granilla. It's a slightly coarser glass powder. It will stick on top of the piece like sandpaper. That's what's happening in here. This thing behind me is really crazy. It's a giant porcelain tile rack. It's made up of a bunch of metal cylinders, and the porcelain tiles go in between. There are 6 pieces per level. They wait here for their turn in the kiln. The thing is, all of this is moved by robots. It looks like that equipment we use to clean the floor at home, but it's a little bit bigger. Just so you have an idea. A shelf like this weighs about 8 tons. Look at it carrying it all by itself. This here is the kiln, and it's no less than 130 meters long. A piece that goes in here takes about 45 minutes to come out the other side. The kiln uses natural gas. It starts at 250 degrees Celsius and goes up to 1,200. This whole process has to be slow. As the piece passes through, different gases are released. These gases have to come out slowly, and they have to come out before the glass starts to melt. Because if they come out after the glass has already melted, a lot of bubbles will form in the pieces, and we don't want that to happen. I said all of that. I'm not even halfway through the kiln. Let's speed this up to make it to the end. Here we can get a good idea of how much a piece shrinks after it goes through the kiln. This one here just went through the dryer, so it's still big. After it's been fired, it will shrink by about 7%. So this one is the same piece. It's just before and after going through the kiln. Porcelain tiles need at least 3 days of rest after coming out of the kiln. This is important not only for the pieces to cool down, but also for them to become flat. Because if you pay attention, this one that just came out is a little curved, and this will correct itself over time. Another step that some pieces go through is polishing. This layer of glass on top is still a bit wavy, so it's necessary to wear down the glass to make it shinier. What comes into contact with the piece is this here. It's a mixture of resin and abrasive. It's kind of like having sandpaper inside plastic. The one with the teeth is a piece that hasn't been in the machine yet. It's brand new. On the other side is one that was just removed for replacement. This wear happens in about 8 hours. It's pretty fast. Polishing only removes a small amount of coating from the piece. There end up being some very tiny little holes, so they have to apply a sealant. This material is made of nanoparticles, very tiny particles. With the help of a sponge, they are rubbed onto the piece to fill all those holes. This sponge here, it may look soft, but it's actually hard and needs high heat to bond the waterproofing agent to the piece. Look, I'm really curious to know how the piece moves like that. It goes in lengthwise, and here in the middle, it spins, and it comes out sideways. It works in a way very similar to a car wheel. There are 2 conveyor belts here. They form a ramp in the middle of the way. The left conveyor belt slows down, and the right one keeps going, so it's as if the part turns to the left. Like a car making a left turn, the left wheel brakes. The right one keeps going, and then the part turns. At the end, there's a stopper here, so the part doesn't spin a full 360. Some parts still need to be cut. This one that imitates wood, for example, will be divided into 3. First, a little diamond wheel scores the part, and then another one holds it and gives it a light tap. See that it cuts perfectly. Looking here, to me it seems like these parts are perfectly straight. But porcelain tiles require very high quality, so they will still go through a process called rectification. Rectification, what is that? The edge, slightly curved, kind of rounded. That's a problem. Because a rounded edge means you have to use a lot of grout. Grout is the paste that fills the space between one porcelain tile and another, and between one ceramic tile and another. So here, what are they going to do? Make this really straight, the edge really straight, at a perfect right angle, so that when you lay the porcelain tile, you can use the minimum amount of grout possible. And then it will create that mirror effect we see. You can imagine that this process is not at all quiet. So everything is done inside a room that is acoustically isolated, where a diamond blade first goes along the side of the piece. And then, a squaring machine makes sure that the top and bottom are at 90 degrees. Here, they grind off about 3 millimeters from each side of the porcelain tile. Let's take this small caliper here, 1.5 meters long, to check if the piece really came out square. I showed it jokingly, but in fact, the porcelain tile will first go through a visual inspection. Then, a machine will check if the dimensions are perfect. If they're not, it discards it, and all of that goes back to the beginning of the production line. It's time to pack these pieces. We usually don't focus much on packaging in Bora Vez or Manual do Mundo, since it's mostly the same process. Here, the challenge is a bit bigger. It's fragile material, extremely heavy. It will have to travel for days on very bumpy roads, so they have to be very careful. Calculate exactly how the pieces will be positioned inside the pallet, whether they will be horizontal or vertical, how many pieces fit inside each box, all of this, so that nothing arrives chipped at the other end. This pallet goes to the building supply store, where you'll buy porcelain tile. This here weighs 1 ton and 200 kilos. 50 meters of porcelain tile, heavier than a car. Worth a like, right?